Students will be able to find compound interest and find an exponential equation for a story problem. You deposit $3,000 into an account that pays 6% annual interest compounded quarterly. How long will it take for the balance to reach $3,500? Well, that's equal to 3,000, and then we have 1 plus 0.06 divided by 4, and that's to the 4t. Let's take 3,500 and we'll divide by 3,000. We get 1.166. And let's store that into, let's say, A. Enter. Equals. Let's take 1 plus 0.06 divided by 4. We get 1.015. And that's now to the 4t. Let's take the natural log of 1.166. Well, the natural log of both sides, really. 1.015 to the 4t. That allows us to bring the 4t down. Natural log of 1.166 is equal to 4t natural log 1.015. Now, that's all multiplication, so we can divide by 4 natural log 1.015. Divide by 4 natural log 1.015. T now is equal to, we have the natural log of A divided by 4 times natural log of 1.015. So we get 2.588. 2.588, and that is years. The half-life of a certain radioactive substance is 9 hours. There are 20 grams present initially. When will there be 3.78 grams left? Well, we know that there's 20 grams initially, so when there will be 10 in 9 hours. So that's 20 e to the k times 9. Now that's a half, and it'll always be a half because we're doing half-life. E to the k times 9. Well, let's take the natural log of 1/2, or natural log of both sides. And natural log of e, that's inverse functions, so those go away. Natural log of 1/2. We can bring, well, let's do this. We can bring k times 9 down. But the natural log of e is 1. E to the first is e. So now that's gone, and we just divide by 9. So k is the natural log of 1/2 divided by 9. So natural log of 0.5. Now we're going to divide that by 9, and let's store that into, well, this might as well be k since it is k. That's equal to negative 0.077. Now n is equal to n naught, which is the initial value, 20, e to the negative 0.077 t. When will there be 3.78 grams left? That's equal to 20 e to the negative 0.077 t. We're going to divide by 20. So 3.78 divided by 20. That's equal to 0.189. That's equal to e to the negative 0.077 t. Let's take the natural log of both sides. And we can bring the power down in front. And then natural log e. But the natural log of e is 1. So now we just have to take the natural log of 0.189 and divide by, let's close that, divide by alpha k. And we get t is equal to 21.632 rounded. How long does it take $300 to double if invested at 9% annual interest compounded continuously? So double 600 is equal to, the initial investment is 300. E to the k now is 0.09 times t. And really the amount is the PERT formula, P e to the RT. But it's the same as this one, really. Just instead of n and n naught, we have a and p. So let's divide by 300, that's 2, is equal to e to the 0.09 t. And we take the natural log of both sides. The natural log and e will cancel each other out, so that's 0.09t. So t is the natural log of 2, and that divided by 0.09. And we get 7 and some change. So t is equal to 7.702, and that is how long? Years. Years. Oh, we got a little graphing here. We have y equals e to the x minus 2. E is 2.718, so e is about 3. So if we plug 0 in on the parent graph, we get 1. Let me change the color. And then 1 is 2.718. So this right here is the graph of, it should be nice and smooth, e to the x. Now we're plugging negative, we're minusing 2 on the inside, so that moves 2 to the right. So 2 to the right, 2 to the right is about right there. So that horizontal asymptote, y equals 0, did not move. That function will level out there. The domain is negative infinity to infinity. The range is 0 to infinity. And there is an asymptote at y equals 0. Now with this one, we're subtracting 2 on the outside. So now let me change color for this. We'll make it green. And then we go 2 down. So here's the parent graph, 2 down. But if we go 2 down, that moves that horizontal asymptote 2 down as well. And that's all. That's it. 2 down. And this goes 1, 2 down. How about right about there? And then it goes up very quickly. The domain, again, is negative infinity to infinity. The range now is negative 2 to infinity. And the asymptote is at y equals negative 2. Jordan wrote an exponential equation to model the cost of gasoline. He found the average cost per gallon of gasoline for 2 years and used these data for his model. If the average cost of gasoline increased at an exponential rate, identify the rate of increase. Write an exponential equation to model this situation. If we call 1990 year 0, then this is the initial cost. Exponential rate. So let's go n is equal to n naught e to the kt. So the initial amount is 1.19. So we have n equals 1.19 e to the kt. Now we have a value to find k. 3.91 is equal to 1.19 e to the k times, well, if 1990 is year 0, 2000 would be 10 years. Another 11, that's 21 years. So this is going to be 21. Let's take 3.91, divide by 1.19, and we get that. How about alpha A? We're going to store that. We just need to store it. Store in alpha A. So we get 3.286 is equal to e to the 21k. Well, when we take the natural log of both sides, 3.286, we just get 21k on the other side because the natural log and e will cancel each other out. Now we have the natural log of alpha A and divide that by 21. So k is equal to 0.056, let's say, but let's store that into k. And we have our model. It's n is equal to 1.19 e to the 0.056 times t. Use your model to predict the average cost of a gallon of gasoline in 2015 and 2017. So n is equal to 1.19 e to the 0.056 times, let's see, 2015. Well, that was 21 years, another 4 years, 25 years. So 1.19 e to the k, there's k, times 25. We get 4.90, and that's dollars. When will the average cost? Oh, no, I didn't need to do 2017 now. So instead of 25, I need to put in, let's see, what's that? 2 more years, 27. So we can go entry, we can back up, make that a 7. So the other answer is $5.49. When will the average cost per gallon of gasoline exceed $7? So when will 1.19 e to the 0.056 t be greater than 7? Let's take 7 and we'll divide by 1.19. And we can store that into A, let's say. E to the 0.056 t is greater than 5.88. And then we take the natural log of both sides, so we get 0.056 t is greater than the natural log of 5.88. And when we take the natural log here, the natural log of E is 1. So t has to be greater than the natural log of, I put that in A, and divide by that value, the 0.056, that's the K. So t has to be greater than 31.281 years. But it says, when will the average cost of gallon exceed 7? So that's 31 years past 1990. So we're going to add 1990 and 31.2807 plus 1990. 2021. So 2021. Why might an exponential model not be accurate representation of the average gasoline prices? The prices may not be increasing exponentially. And they probably aren't. Exponential growth happens very quickly. With your partner, try to get 5.465 for the answers on this one and 47.749 years on the next one.